Hello friends, now I am going to discuss one problem where RCC member is subjected to bending moment of 250 kilonewton meter and also a tension of 100 kilonewton. That is, we are going to discuss the design of an RCC member which is subjected to predominantly bending moment and low value of tension, such as the case of a framed structure in a multi-story building. Now, for this kind of problem, what is the practice generally followed at present? Yes, some people are using the charts available in SP16 for tension and bending moment. That charts, use of these charts is perfectly okay, but it is very uneconomical. This chart gives the equal reinforcement for compression zone and tension zone. Use of these charts is okay if tension is of high value and bending moment is of low value. Therefore, use of charts given in SP16 for design of members subjected to predominantly bending moment and low value of tension is not okay, because providing equal reinforcement in compression zone and tension zone doesn't make any sense. There are some people who are designing this section only for bending moment and ignoring this value of tension, which is very small. This approach is okay in the sense the structure will be definitely safe even if you ignore this value of tension. But it is not the correct procedure to ignore this value of tension, however small it is. And there are other people who leave it to the software. The software program is available for integrated analysis and design. These software programs give the value of ASC and AST, which are unequal. It is perfectly okay. But the fact is, each and every software provider is giving different value. In my opinion, they are giving the value of reinforcement, which is essentially calculated from the value of bending moment, and then they are adding some reinforcement for the sake of tension in the compression zone and tension zone. And each and every value is different for various software programs. That means they are not based on the equilibrium equations and also the compatibility of strains. This problem is not addressed in the IS code or SP16 or in any textbook. That is, design of a member subjected to predominantly bending moment and low value of tension by limit state method is not addressed in SP16 or IS code or in any textbook to the best of my knowledge. Therefore, I have taken up this for the discussion. Here, these are all factored forces and beam size is 250 mm breadth, 500 mm depth is the overall. We are having the cover of 50 mm on both sides, tension zone and compression zone. This is the compression zone reinforcement ASC. This is AST. The problem is to calculate the value of ASC and AST. Before proceeding to the problem, let us calculate all the parameters required for using these equilibrium equations. First, we will draw the strain diagram, which is a linear one. The strain in the concrete extreme fiber of compression zone at collapse state is taken as 0.0035. The strain in the tension reinforcement is taken as 0.87 Fy divided by Young's modulus plus the residual strain of 0.002. This works out to 0.0042 for Fy 500. Once you fix these strains, that is the strain in concrete at the ultimate stage 0.0035 and the minimum specified value of strain 0.0042, this becomes the balanced section. Now the depth of the neutral axis can be found out in the proportion of these two strain values. This is the depth of the neutral axis XU and this is D minus XU. because the overall this depth is d. This is xu and this is d minus xu. Proportion of xu and d minus xu is same as the proportion of 0.0035 and 0.0042. Therefore, we can easily find out the value of neutral axis for this balanced section 207 mm, which is also equal to 0.46 d. Now we will draw the free body diagram. The esteem fiber stress is 0.45 FCK, and then we have this rectangular cum parabolic stress block. That C1 denotes the compression offered by the concrete. This is equal to area of the stress block into breadth of the section. So area of the stress block into the breadth of the section, here it is given 0.36 FCK into breadth into XU divided by 10 power 3, that is equal to 466 kilonewton. This is the compression offered by the concrete. Now we have to calculate the strain in the compression reinforcement so that we can get the value of stress in the compression reinforcement. Esteem fiber strain being 0.0035 at a distance of 207 mm plus XU. Now the strain value at a distance of 207 minus 50 mm can be found out by linear proportion. It is 0.0027. Corresponding to this value of strain, the stress in the compression reinforcement can be obtained from the table in SP16 in page number 6. So strain in compression reinforcement is obtained proportion to the distance from the neutral axis, and this is equal to 0.0027. And based on SP16 page 6 table A, value of compressive stress in compression reinforcement is 410 Newton per millimeter square. Now we have already discounted the area of concrete occupied by the compression reinforcement. Now we have to avoid the duplication. Therefore, we have to get the net stress in compression reinforcement, which comes to FSC minus the esteem fiber stress 0.45 into 25. This works out to 399 Newton per millimeter square. Approximately, this will generally come in the range of 0.8 F5. So this is the stress in the compression reinforcement. Now we will also get the arm distances for various forces. The external tension 100 kilonewton is acting at the mid depth of the section. That is the general assumption. Therefore, the arm distance for this external tension 100 kilonewton is 200 mm with respect to the tension reinforcement. Now the CG of the rectangular cum parabolic stress diagram is at a distance of 0.42 times XU measured from top. This 0.42 times XU is equal to 0.42 times 207. That is equal to 87 mm measured from top. Therefore, the arm distance for C1, that is the compression offered by concrete, is 363 mm with respect to the tension steel, because the effective depth is 450 mm minus 87 mm, it is 363 mm. Now, what is the arm distance for C2? It is at a distance of 50 mm from top. The effective depth being 450 mm. The arm distance for compression steel is 400 mm measured from tension steel. Now we will use the equilibrium equation sigma m is equal to 0. Now this external force is acting in the clockwise direction. The movement due to, we will apply the equilibrium equation sigma m is equal to 0 with respect to the tension reinforcement. Now this external moment is acting in the clockwise direction. The movement due to external tension is acting in the anti-clockwise direction. Movement due to compression offered by concrete is acting in the anti-clockwise direction. Movement due to compression offered by the compression reinforcement is also acting in the anti-clockwise direction. clockwise moment should be equal to the anti-clockwise moment. All the three forces, this external tension, C1 and C2, all the three forces are acting in the anti-clockwise direction. So sigma m is equal to 0. We are taking the moment about the tension reinforcement. This is the external moment. This is the external tension. This is the arm distance with respect to tension reinforcement. This is the compression offered by concrete. This is arm distance for C1 from tension reinforcement. C2 is the value of compression reinforcement, and its arm distance is 0.4. Now, the only unknown in this equation is C2. It is obtained as 152 kilonewton. Now, area of compression reinforcement is equal to this compression value divided by 399, which is nothing but the stress in the compression reinforcement. Therefore, area of compression reinforcement works out to 381 millimeter square. Now, you can fix the numbers and diameter of the reinforcement. Now we will apply the equilibrium equation. Sigma H is equal to 0. Now you can see this external tension is acting towards left. C1 compression in concrete is acting towards left. Compression in reinforcement is acting towards left. The internal tension in tension reinforcement is acting towards right. Forces towards left should be equal to forces towards right. So that sigma H is equal to 0. This is 200 this is 100 kilonewton external tension. This is 466 kilonewton compression due to concrete. This is 152 kilonewton compression in compression reinforcement. All the three forces acting towards left. T is the only force acting towards right, that is tension in reinforcement. The unknown T can be found out. It is 718 kilonewton. Now the stress in the tension reinforcement for the minimum specified value of strain is 0.87 times 500. Therefore, the area works out to 1650 millimeter square. Now you can fix the numbers and diameter of the reinforcement. This is the procedure to be followed for calculation of ASC and AST in the case of RCC members subjected to predominantly bending moment and low value of tension. This is my opinion. And suppose even the tension is high, the use of SP16 charts is perfectly okay when tension is high and moment is low. Even in that case, that is the point of using that chart. AST is equal to ASC is equal to bending moment divided by the lever arm. Lever arm is nothing but the distance between the tension reinforcement and compression reinforcement. That is D1, M by D1. Moment divided by this lever arm divided by 0.87 Fy plus the tension divided by 2 divided by 0.87 Fy. This gives the area of steel in compression zone and tension zone. This formula can be used instead of the chart. If you use even in the case of members subjected to high tension value, there is no point in using SP16 chart. You can as well use this single line formula. The reinforcement value given for AST and ASC as per this formula is same as that obtained by SP16 chart. My suggestion to all of you is please put this system in practice in all the problems. Also, request you to take it forward for incorporation in IS 456 code. So far, it is not addressed in IS code or SP16 or textbook. Now, IS code revision committee is headed by Professor Murthy of IIT Madras. Please take it forward to Professor Murthy. Already I have written to him. Also, I request you to get the calculations, the values of, I also request you to get the validation for whatever formula which is built in the software programs from the service providers. You have every right. It is mandatory for those vendors to give the validation for the procedure which is inbuilt in the software program. It has to be verified that the procedure which is inbuilt in the software program is based on the equilibrium equations and also the compatibility of the states. That is my request. And once you take the stress and compression reinforcement as 0.8 Fy, we can very easily arrive at the formula. Here I have drawn the strain diagram so that I can get the value of compressive stress in compression reinforcement exactly as based on the strain in concrete. If you are approximately taking the stress in compression reinforcement as 0.8 Fy, this much calculation can be avoided. We are designing this as a balanced section. It is very easy to arrive at a formula for ASC and AST, and that has been given in this blog material, which says available for free download in my website rgnsite.wordpress.com. That formula is derived and it is given in this blog material, which is available in the website rgnsite.wordpress.com. See, this is the my address of my website. This is the address of my website. https://rgnsite.wordpress.com, including this YouTube material and also other load cases such as compression and bending, max predominant value of bending and low value of compression, and given the reinforcement, calculation of the capacity, and that is the analysis problem. All the problems are available in the blog material, which is titled as Design of RCC flexural members subjected to predominantly bending and low value of compression or tension. This blog material is available for free download in my website, and the address is https://rgnsite.wordpress.com. Please visit this site. The download is free for all the materials on RCC design, steel design, strength of materials, structural analysis, matrix methods, etc. It includes nearly 500 university questions. The download is free. Please visit this site rgnsite.wordpress.com. Also, I request you to please give your comments. I am also requesting you to go through my other videos. In this video, you can see one icon R below the video. If you press that icon R, you can get the complete list of my videos. Request you to give your comments, please. Thank you all.